taking a picture.
Yeah. It is, in research circles, it's becoming something of a standard tool just because of the model that it uses, which is interesting, and you don't necessarily need to know anything about it. If you're going to be working on the floor planning stuff, you might not even need to know how it works. We can talk about whether or not that'll be important. If you do power delivery network modeling stuff, then you might need to know a little bit more about how that works, for instance, because then the power stuff will be more important. But there would be a way to work on a project that really just focuses on that block,
I see.
for instance.
Yeah.
Okay.
So
But it's open source. It's not bug free.
Is that what?
Bug free.
Oh yeah. You said this.
Yeah. Building up the software infrastructure to make all this work is a real hassle, as you observed. The student that worked on the power delivery network modeling is a graduate student at University of Virginia.
So have you ever used this software before?
Have I ever used it personally?
Yeah.
No.
No. Okay.
But I know people who have.
Okay.
Yeah.
Okay.
And the Runja is the student that has done the power delivery network
Charles,
stuff.
is this one like involved in every project, right? Like in everything?
Because it's mentioned in every project, but it's more used
In the power, yeah, the
yeah,
C4
in the
pipe
power,
something.
yeah.
So the floor planning tool and the power delivery network modeling project, they
Yeah.
evolved together. So the case studies for this draw on this because it was being used in the power delivery network modeling
Okay.
project as well.
Yeah.
But there are other ways to get inputs for this in order to develop it and so on.
Yeah.
Okay.
So Charles, what's your opinion on choosing the project?
Because what I want to start with is something that looks more doable. Like, in terms of there's more probability that we won't end up and say, oh, no, we don't know how to do this. So,
Well, my recommendation would be to work with the floor planner because
Okay.
there is a way to work with just it. You never have to touch anything else.
Okay.
You don't have to figure out how to integrate it with massive software infrastructure
Oh.
that none of us understand.
Oh, sorry, I have a question. Maybe this question seems maybe too early, but I'm curious. Let's say we finish this. Do you think how long would it take if we choose this? How long would it take us?
I don't know.
Oh, okay. Oh, let's assume we finish this in 2 months. Let's say. I'm not sure. Well, assuming maybe we finish it in 1 year, we can finish it. Well, it happens. Well, let's say we finish in 2 years. So,
2 months.
2 months. Yeah, sorry for that. 2 months. So after that, we still can do some other steps, right? We still, as you said, as long as we want to work, we
I think as long as you want to work on this, there will be more stuff to do on this.
All right.
I can tell.
Okay.
Yeah. There's.
Yeah.
So
So what I'm asking is if let's say we choose doable but small steps. So after we finish, let's say we have finished a week, but we always have something to do, right? Because I want to continue working, so that's my only concern.
You won't run out of things to do.
Pardon?
You won't run out of things to do.
There's endless
Okay.
stuff.
Yeah, endless
You can
thing.
always be better, even it's what's already
Yeah,
there.
yeah,
you
yeah,
can improve
yeah.
on it.
No, I mean I think the best case scenario would
Yeah.
be that we do enough work on this
Yeah.
to actually do some experiments and write a paper.
Okay.
I think that will probably be a stretch for 4 months.
Okay. Stretch? What is stretch?
Meaning, I don't think that it's likely
Oh.
that you'll get everything done and get the experiments done
Okay.
and write a paper in 4
Okay.
months.
Okay.
But regardless, however much time you decide to spend on this summer, you can make a real important contribution to the development of that tool.
Okay.
Because the evolution of this,
Okay.
this project started off as a course project for a graduate level computer architecture class.
So you mean someone already did it before, or?
Well, you're going to be getting some software,
Okay.
which is, it's actually,
Oh,
So it's freely available now. It's been posted as a
Okay.
technical
Oh,
report. You can go and
so what
download
you
it.
said is this, I mean, this field is already as a class or will be as a class?
So the software that you're going to get
Yeah.
was the result of a course project from 2 years ago, a graduate course at the
Okay, it's
University of
programmed
Virginia.
by some master student or
A PhD student.
student.
Yeah.
Okay.
Okay, and it's not complete. We just submitted a paper
Yeah.
based on it in the last couple weeks. At the end of
Yeah.
May. At the end of May, we submitted a paper. And if you decide to work on this, I can send it to you
Okay.
because it's a condensed version of the technical report and has been revised to be a little bit more clear about how
Okay.
everything works.
Okay.
Okay.
And so I can give you a detailed spiel on this if you're interested.
Zooming.
What?
No, zooming.
Zoom.
Yeah. We'll zoom in.
Yeah.
So in VLSI CAD,
Yeah.
the floor planning problem is you have, I'm going to just draw an inverter again. Because that's-
Oh, you just did.
I know, I'm going to draw a small face so I have so I have space. So the VLSI CAD problem
Yeah.
is first you have a circuit and you know that you want to implement this, and so then you transform it into this,
Okay.
and then this gets transformed into some standard cell which looks like what I had previously drawn with the transistors,
Yeah.
and they're wired up and so on, right? Except you don't just have inverters, you have lots and lots of gates. They're different. There's different ways to optimize what goes in there, and then eventually you have a design where you have your standard cells laid out in rows, for instance, or you might be dealing with larger blocks of logic, and you have to figure out where, given that these things are connected in these different ways, where do they all go so that we can maximize performance, minimize power, minimize area, or whatever. Floor planning, done at the gate or module level typically. Okay. In system level research, where our blocks aren't inverters or AND gates or even adders, we still have a need to do floor planning, but we're talking about cores. We're talking about big blocks of memory, we're talking about processors or large elements within processors. And so we might have a multi-core architecture, and maybe it's heterogeneous. So we have processor 1 and processor 2 and cache 1 and cache 2. Is that the best way to organize them? Who knows? We need to have a way to evaluate this and explore different options. And so the purpose of, but the problem here is that, especially if we start talking about a massive network on chip, where we might have 16 cores and memories and memory controllers and all sorts of stuff, maximizing performance isn't, where performance is just the inverse of latency. That doesn't work here anymore, because we're going to have a network on chip, and really all we care about is that the links in the network are short enough to meet network timing. We don't want to minimize the longest critical path necessarily. We just want to meet network timing. And power means something different, and area means something different, and so on. And so the purpose of the architectural floor planning tool is to give architects a way of laying out a system very early on in design, so that they can evaluate things like area, but then also be able to look at things like temperature, which we need a floor plan for, because if this is a really hot core, we know that it's going to make this one hotter, and this one hotter, and this one hotter, and so on. So maybe if this one's also really hot, maybe we want to move these so that they're at other ends of the system to minimize the temperature gradient.
But sir, do you have a reference, how do we do those? Is it by luck or?
Your algorithms.
Yeah, we do have some reference to
Well,
follow.
the way that people do this now
Yeah.
is by hand. So you, oh yes, so you would construct a floor plan,
Okay.
and then you would do an evaluation, and you'd say, well, the temperature's too high, so I need to move stuff.
Is it
And
is it like a real or it's just simulation?
Simulation.
Simulation.
right? Because you have to. This is early design.
Okay.
So far before prototyping, because no one takes an idea and then synthesizes it, because you can't go up and down
Yeah.
the design stack too many times. You need to have a real good idea about what your system architecture is going to
Okay.
be before you proceed to the next
Okay.
step. And this gets obviously harder if you have heterogeneous blocks. And so what the architectural floor planning tool is intended to do is to give designers, especially architects, who have an idea about what ought to be close to what else, processor 1 should be close to cache 1, whereas this floor planning tool, it will look for connections between these guys, and it'll say, well, all the wires between these ought to be short because there's lots of wires, and so we're going to try to put them close to each other, but it's just by random chance that it finds a good organization. Whereas the designer has some intuition, P1 should be close to cache 1. And so there's a way in the specification, the tool is now called ArcFP. I don't think that's in the report that I sent you. ArcFP allows you to specify the relative position of different components in the floor plan. That is the basic idea, to give our architects a fast way to develop a floor plan which can then be used along with tools like McPat and other things like that in order to answer relevant questions like, what is my IR drop going to be in the power delivery network? What is the maximum temperature going to be? What is the reliability going to be? And so on. And the problem right now is that ArcFP is missing some pretty important features in order to make it a truly useful tool. And that's what you guys would be working on. You'd be adding in support for the things that are currently broken or just not included.
Okay. Sounds concrete.
Good.
Yeah.
Yeah.
Same here.
And the benefit for a short summer project is that you could work on this and never touch any code outside of this. So you don't need to know anything about McPat. You don't need to know anything about Hotspot. You don't need to know anything about anything else. You could just live entirely in the C++ in which ArcFP is written.
Okay.
So we basically use C++ in this case, right?
Yeah.
Okay.
That sounds good.
Okay.
Yeah, sounds like
At least it's not something that there's not a lot of documentations like ADL.
Oh, but see, that's the great thing about a graduate student research project. There's no documentation, so you get to go and, but there's no documentation, but there's people that have been using it, and we still have access, obviously, to the graduate student who wrote it. And so the idea would be that you're not going to be working in a vacuum. We can, if you run into interesting bugs, we can get help figuring out what the problem is. So.
That
And it's
sounds-
not nearly as extensive as ADL either, so it'll be a lot easier to understand.
Okay.
Good. Okay?
Yeah. So Charles, are you going to choose this as like a primary idea?
Yeah, I guess this is very
Acceptable.
well. It's interesting and it looks like I said, it's